Hey, good afternoon, fellow PMI team members. Welcome to the last edition of our Lunch and Learn for 2022. This is Brian Russell. I'm the chapter's Lunch and Learn coordinator. Today, we're going to hear from Steve Thomas in regards to green energy projects, tools, and considerations for balancing opportunity and risk. You can see it on the screen there. But first, a couple reminders. After the session, a couple of days, you'll have access to the materials as well as a recording and instructions for claiming your PDU unit. So be watching your email, whatever email you have registered with the chapter for that content. And then I wanted to give you all a reminder that this evening the chapter is hosting a PMI Western Idaho chapter networking bingo event. If you have questions, want to check into that, then check out our PMI Western Idaho chapter website in the events area. You can learn about the location, the timing, and then as well as what that is going to be all about. So take a look at that. So today, as I mentioned, we've got Steve Thomas with us. A little bit about Steve. Steve is a segment manager in the Power Systems Division at Wheeler Cat. Steve develops business opportunities around renewable energy and emerging technology. He loves helping customers and partners navigate an increasingly complex energy landscape. While fantastic evolutions in technology and funding are moving the industry forward, we still combine many different solutions to meet customer needs. Steve works to join the best finance, incentives, technology, and equipment into innovative hybrid energy solutions. So with that, I am going to hand it over to Steve, and we're going to hear all about green energy projects, tools, and considerations. Steve, it's all yours.
Fantastic. Thanks so much, Brian and George, for getting me up and running. Can everybody hear me? I think that's probably the first thing, is we want to make sure you can hear what I'm saying. So I've been in the industry for, in the green energy efficiency, energy utility space for probably 10 or 15 years at this point, working on a number of efficiency and generation projects. So I've kind of been all over the place, and a lot of this is going to be, experience-based, industry-based kind of ways for us to improve how we work with green energy projects. So one of the interesting things that we have maybe in the energy industry that we don't have anywhere else is nothing is standard. So everything that we do is probably some kind of custom project. We've got, we don't really have the silver bullet, the universal solution to green energy, to energy in general. And so we have to combine everything into these hybrid solutions, something that works, but maybe is a little more complex than we like to get the same results. One of the first things I want to do is show a little video. Just a couple bullets here. We're going to talk about hybrid solutions, some economic gaps, and performance assurance. Kind of these are the tools that I'd like to talk about that can help us navigate this better. So first thing I want to do is start off with a video about microgrids from Caterpillar, from our Tanaha Proving Grounds.
We're about 5 miles from the nearest town. We're far enough from the nearest road that we're off the electrical grid. We have to generate our own power to run the facility. And we have a lot of power demands here. We're doing work in the shop, we're welding, we're doing office work, we're doing machine teardowns and builds. It's a fully functional Caterpillar facility. And on a normal day, you can hear the generators running at the same time that the sun is shining more than 320 days a year.
when we started to look at the sunlight conditions, the renewable energy availability here at the Tucson Proving Grounds, it was an ideal location because the sunlight is strong. It is a warm climate, so the solar power technology that we're using, which is CAT branded, it really excels in this kind of a hot climate. We started looking at the financials, paybacks. We began to look at integrating energy storage, including lithium ion and ultracapacitors, to bridge through those cloudy periods. And we can now achieve 33% fuel reduction with the PV system that we've installed here.
And then as well, all of the CO2 emissions that are a product of burning that fuel. So our expectation is to save more than 1,000 tons of CO2 emissions a year just at this facility.
I would say a renewable microgrid, which is really what we're talking about here, is integrating in renewable energy, whether that be solar or wind or whatever renewable energy source you might have, with our traditional generation, along with potentially energy storage or other elements to provide a stable grid. Today, though, when solar panels and all the costs associated with solar have come down like 90%, now it makes sense even if with normal fuel prices, we can produce, the cost to produce solar energy is below what it costs us to produce diesel.
So that's really what I think is going to happen is the broad deployment of microgrids, helping electrify the rural communities in the world, as well as complementing the traditional hub and spoke or central generation that we have in a developed country. So reducing emissions, enabling customers to use local resources, those are both sustainable. Enabling customers to have sustainable businesses, so by providing that lower cost of electricity or providing electricity to those who've never had it before, certainly part of our sustainable development mission. I mean, this project is really in the sweet spot of where Caterpillar can provide sustainable solutions for our customers and dealers throughout the world. It's really an exciting time. We really feel like we're changing the world with microgrids.
All right. So George, the poll questions, can we do the one about interest in green energy? Kind of see where everybody sits on that.
That is already up and available in the polls.
Oh, man.
Yeah. If everybody wants to just jump over to the polls on the right-hand menu and answer that first poll. What is your experience or interest in green energy?
Oh, you guys are so good to me. Okay, very good. All right.
Like we're getting some answers, some responses in.
All right.
And you can see them as well, Steve. If you click on the poll, you vote, and then click on the poll, you can see the responses coming back. So far, renewable energy ahead by 1 vote.
Let's see. All right.
Yeah.
I am not getting the results of the polls, so
okay.
Is it kind of spread?
I'll share them with you. So ESG is 6%, renewable energy 44%, cost reduction 19%, and brand new to the green energy discussion 31%.
All
So
right.
renewable energy and the brand new are the top vote getters from this audience.
Okay, sounds great. I did want to talk a little bit about grids, microgrids, what a hybrid solution is from a CAT perspective. We are one of the few equipment suppliers, service suppliers that are doing a full end-to-end solution in the microgrid space. So we've got energy storage, solar panels, traditional generation, generation using alternative fuels, all these kinds of things, remote monitoring platforms, controls to integrate that into remote areas or to be grid connected to utilities. So that's an important kind of distinction to make. So generally a microgrid is going to be independent of a utility. A lot of renewable projects have to integrate into utilities, so maybe require a little more equipment than just a standalone solar project or something like that. There's a lot of a lot of complexity to the biggest machine and regulatory monster that's ever been built in the history of mankind, our utility grid. And so for us to be able to integrate and respond to that in ways that are effective and allow them to continue, there's quite a bit of nuance to green energy projects. So that's one of the things that we do at Caterpillar. We are one of the biggest and oldest generation equipment manufacturers in the world. We've been building generation equipment since the 1930s. So 80 plus years of experience, over 500,000 installations for energy equipment worldwide, and in response to the changing economy for energy, we've integrated renewables and all these solutions again into the offerings that we have. So that's one of the things that I love about being with Caterpillar, is that we have a lot of experience to put behind this. We have a lot of innovation. Caterpillar is an engineering company. Wheeler is one of their dealers, and we're able to provide really innovative solutions for people across the board, from investor-owned utilities and munis and co-ops to commercial folks, all the way down to residential. So the whole gamut, which I think a lot of folks, when they think renewable energy, they're either thinking rooftop solar or utility scale solar, and that's the end of it. And we've found by our experience that it's a little more complex than that. And that's why it's important to have the right partners and the right equipment. And that's one of the value adds that we bring, is that we've got a one-stop shop solution to microgrids. Wanted to talk about solar for just a minute. Generally, when people think about renewables, it is solar. That's what they think about. They may think about wind, but generally it goes directly to solar. Well, on the screen here, we've got a rectangle, and that rectangle is our 24-hour load block that we need to supply power for 365 days a year. Well, that beautiful, rainbow colored cigar in the middle is going to be your solar production throughout the year. So unless you have a load that absolutely follows that perfectly, which is unlikely, there's going to have to be some kind of transition from solar into grid or into storage or into some alternative means of generation to continue to meet your load. So that's an interesting thing I like to bring up. Solar is fantastic. It's affordable. It's generally reliable, all of those things. However, it is not the ultimate silver bullet solution. And unfortunately, as I'm talking to folks, they're like, well, we want to do this complete off-grid, microgrid solar solution to, our industrial or mining process. And then when you tell them that for, their 3 megawatt load, you need 15 acres to put solar on, eyebrows raise, and I can do the same thing generating diesel or natural gas on essentially, 2 semi-trailer beds. So there's a little bit of a maybe understanding gap that we work through as we do these things. Solar is a fantastic solution. It gets better and better. 10 years ago, we were 100 watts in a panel. Now we can do 500 or 600 watts in the same footprint of a panel. So the technology, the efficiency, the energy density of solar has gotten better and better and better. The price comes down. However, there's still limitations that we need to address. Whether that's through pairing this with the grid and being able to transition it smoothly, or whether it's having on-site storage and generation to smooth it out. whatever it is, that's where the hybrid part comes in. Solar's great, and it needs a little help as it continues to grow. This is a chart that talks about the Tanaha Proving Ground, about a little bit of the economics here, what that daily load profile looks like. Again, similar rectangle, what that would look like here. You've got a load curve starting at 1 o'clock in the morning and ending at midnight. And your yellow is your solar. Your blue is going to be your daily load. Notice that there is quite a bit of mismatch there. As you extend battery storage, you're able to meet part of that load with the battery storage, save fuel, not run your generators, in an off-grid application. In a grid application, all of these areas are going to be what the grid serves, right? Your solar, your self consumption throughout the day will be in this yellow part. If you've got a net export agreement with the utility, this overage here can be absorbed, and net metered in some cases. But again, not the perfect solution. That's why we require, other technologies to integrate with solar to continue to meet the loads. The idea here is to manage the loads and manage the generation so that they're balanced and neither one suffers a ton in the process. Wanted to quickly talk about energy storage. This is a very exciting picture of a Connex box with a cat sticker on it. But inside are the guts with transformers and battery storage and all kinds of controls that can do pretty amazing time shift and stabilization things. Great solution. Lithium ion's kind of the standard right now. There's lots of technologies being batted around. One thing about Caterpillar is we do roll out some tests, some field test units, some new technologies. But at the end of the day, when you're buying something from CAT, we stand behind it. We use established technologies and do a lot of R&D to make sure that what we're selling, what we're implementing, is going to be there for the long haul and do the job that it's asked to do. One of the other things that I want to talk to a little bit about is this integration with the grid. Without going too far down the rabbit hole on utilities, they do a lot more things than just turn on your lights. And it's a very, again, probably the most complex system that we've ever built in the history of mankind. So where we put these renewable resources, these storage resources, these firming and shifting resources matter a lot. The closer we put them to loads, probably the better. We're able to get a lot more benefits out of it. Anything from maximizing a customer resource to deferring investment in lines and wires for utility, to time shifting and being able to take more renewables on, all the way down to black start. If the power's out, these batteries in the right application can have black start and restart capabilities, which are pretty phenomenal, especially with the grid being as distributed as it is. So lots of different things here. The big takeaway is this is an interim technology. I feel like it will continue to improve, and storage will get better. We're able to bring in more renewables because of storage, because of fast response generators than we ever could just throwing them on the existing grid. And I think that's one of the big takeaways about energy storage. CHP and cogeneration, we've got traditional fuels, traditional reciprocating engines. Being able to replace some of the thermal needs, some of the hot water needs in facilities allows us to multiply the efficiency of that unit significantly. And that's what cogeneration is. We're taking that waste heat, using it to heat water, using it for thermal loads in facilities. And so replacing two things with one, we're replacing our water heating and our power generation. So that's why it's a cogeneration opportunity. And combining solar storage, cogeneration into a microgrid is essentially the Caterpillar solution to microgrids at this point, and it continues to evolve and get better. But those are the main components outside of kind of the controls. How are we doing on time? We're already halfway there. This is the kind of the Caterpillar end-to-end solution with, and we provide not only just the equipment, but also the monitoring and finance and, you know, an unrivaled service network throughout the world. It's not just, you know, in Utah or Idaho or, you know, the continental US. I mean, we've done projects around the world for any number of governments and customers, specifically us, but also, you know, our dealer network, which is, I think, 75 here in the US and 90 something worldwide. And so we've got dispatchable technicians, parts, and, you know, reliable service throughout the world. So all of these things allow us to be a leader in the energy space. Before we jump into economic gaps, can we do the second poll, the energy consumer awareness? So we talked a little bit about your interest while you're here, but how many of you folks have delved into green energy at this point in some way as a consumer, not necessarily as a project manager, but the range of I pay a bill all the way up to, you know, I essentially have a microgrid on my home are the options here.
Yeah, so if you want to jump over to the polls on the right menu and pick your choice and then hit submit response. Yeah, we got some votes coming in, Steve.
All right, there we go. All right, I'm aware of my energy. That's always a good start, right? Awareness. We know what we're spending on it. That's important. 35% have done something about it, which is pretty phenomenal. And 13% have solar on their homes in Idaho. That's pretty cool.
Yeah.
Very cool. If you have solar on your home, you probably have seen at some point some kind of economic analysis on, hey, if you invest here, this is how much you'll save or how much you'll pay back or replace off your bill, and, you know, that kind of thing. Well, that goes throughout the range of these projects, right? We've got economic considerations that are significant in doing green projects. If there was a magic bullet, you know, the economics would probably be pretty poor for it, right? Like, where there's a lot of R&D, there's a lot of kind of exploratory things happening within the energy space, and let's say we had a great solution, it may be pretty pricey, and that's what we're finding in a lot of cases, is that regardless of what the solution is or how it integrates into our existing system, that generally, and I found this in energy efficiency and doing hundreds, maybe even thousands of commercial efficiency projects. If it's an apples to apples economic decision, if there is a straight payback, a simple payback, you know, under 3 years, or making some behavioral changes that pay for themselves in a year, the sell to do that is not very hard, right? Generally, competing with other priorities, if there's a straight economic apples to apples payback, you're good to go. You're doing the project. It makes a lot of sense. That happens. When the challenge comes in is when we have a project that makes sense, but there's an economic gap in that project, right? Let's say currently I'm paying 9 cents for my energy, and maybe I can get solar for 7.5 or 8 cents. Well, I have to make up that I have to make up that 9 cent power first, and then that incremental cost is where my savings come in, right? Like I'm replacing something, so I have to pay off that replacement first. And so those incremental costs, those investment costs, the replacement costs are somewhat absorbed into the utility and into other things. So to make these projects work, we need to identify those economic gaps, make sure that we understand what those costs are, and be able to account for those gaps, right? So maybe I've got an ESG goal of reducing my carbon footprint or carbon emissions by 5% or 10. And those are generally pretty easy. Let's say I've got a goal of 30%, which is a significant lift generally. I've got to find in my mix, in my capital projects and my energy management projects and my investment in renewables, what the difference is between what I'm currently paying and what I'm going to pay, and where those ESG things are funded, right? Like I may be able to get a 7 or 8 year payback, but generally my capital projects are a 5-year payback. How do I bridge that gap, right? So that's one of the complexities of green energy projects, and here in the economic gaps. And I wish that the diesel was as cheap as it was in here. I think it was $3 when we did this chart, and it's $6 now. But we've got these costs here that are pretty low levelized cost of energy, but we have to essentially replace that entire system, right? We're replacing the diesel, which is good, but at some point there's a mismatch, right? I've already invested in my diesel generators or my grid, or whatever the case is, and so to additionally put something on top of that, even with a good levelized cost of energy or project life, there's some things that help do that, right? One of them is financing, right? There's the idea that I have to buy a capital project and put it on. In some places that may not work. Other places, the utility may have some incentives for us to produce electricity and sell back to them. And so a PPA or a lease might make a whole lot more sense than a capital project if I can get favorable financing terms, right? And so instead of me tying up all of my capital into a renewable energy project, I can make it an operating expense. And that allows me then to produce energy kind of at a competitive rate and pay it off as I go along, rather than having my capital compete. And that's more where the energy industry is going, at the utility scale, somewhat at the commercial scale. There's incentives available. So whether that's tax equity incentives, like the Inflation Reduction Act, is talking about 30% tax credit on renewables. And then as that evolves, it'll be a carbon intensity credit, which will be great for emerging technologies or retrofit on buildings, those kinds of things as well. But that allows, kind of that 30%, that 25% that is generally a gap to be closed significantly. One exciting thing about the Inflation Reduction Act is previously it was really complex to do a tax equity project. If you were doing it for a nonprofit or utility or government, somebody who didn't necessarily have any kind of tax liability, to be able to go in now and have a direct pay option for those folks that don't have a tax liability will be a game changer. So, nonprofits and governments that couldn't do these projects before, or there were a stretch, or they had some economic gaps, get those filled with a cash payment in lieu of a tax refund, which is a pretty phenomenal advancement in the finance and incentive industry. So, and then one of the things that I showed earlier was the battery storage kind of round chart there, and all of the different benefits without getting too energy nerd on it, you know, there's reserves. So when I have a load, I have to be able to meet the max load at any given time as a utility. So having spinning reserves, which is something that I can immediately dispatch, or other reserves that I could bring on pretty fast if I needed to. Different trading intervals. So I've got day ahead and 5-minute and real time markets. I've got frequency and voltage regulation. I've got all these other things that may or may not go through someone's mind as they're putting together a green energy project. The more I can monetize those, the more I can market those to the utility or to a regional transmission organization or balancing authority or an imbalance market, which may be all of those combined, the more I can take out these layers of complexity and monetize them, the more valuable then my resource becomes. And so instead of just saying I'm selling my solar for 9 cents, or I'm replacing the grid power that I had for 9 cents, maybe there's a value stack that makes it more profitable for me to do that. And it's all a regulatory thing. One thing I wanted to talk about a little bit too is that regulatory complexity. There's a little bit of a saying in the energy industry is if you know one utility, you know one utility. That's it. Every location, every even the same location, a different sized project or a different type of project or a different customer may have different rules that apply to them. Maybe the investor owned utility, Idaho Power, has rules that one of the munis doesn't have, or vice versa. Or I'm trading something across the lines to Oregon. There's a whole different set of rules for Oregon's carbon reduction portfolio standards than there are for me sending it the other way into Wyoming. So there's lots of complexities here that I think many times folks are like, well, I did it in California, or I did it in Hawaii, or I did it at my site in Oregon. I'm sure it'll work the same here, and I think that's another kind of economic piece that has to be considered. Make sure that as you're vetting partners and working on projects that you understand the differences of different places. Like my net metering policy in Utah and Rocky Mountain Power is that I have a net billing policy, and that I'm paid about 1.5 or 2 cents for my energy when it used to be a 1-for-1. And so that changes the economics significantly. Tax credits make it more doable, but really you have to have an idea that there may be more than just an economic argument to doing some of these green energy projects. Maybe it is a carbon reduction goal. Maybe it is a self-consumption or resiliency goal that I have. And as long as you can put a number to that and find funding for it, these projects become a lot more doable. Again, the project justifications, like maybe it's I'm marketing it. Maybe there's a problem with the grid and it's a math equation. I'm going to have to upgrade the substation, and I'm going to have to do all this work to get better service from the utility, or I can do renewables in a storage project that's half the price, and allows me to kick the can down the road, essentially. So the grid constraints are one good reason sometimes to do these projects. With the Inflation Reduction Act, with some of the rural finance opportunities, with some of the DOE grants, with tax equity, all of those things allow these projects to be more available. And a lot of the financial institutions, the commercial money, although the interest rates have gone up, are going to consider these projects more and more because of the incentives around them. So there's going to be as strong as the industry was before, there's going to be a definite push to do more and more of these projects. Private financing, there may be grant foundations or private banking or that kind of thing that want to get involved. There's going to be green energy funds. There's going to be all kinds of new and innovative things. Maybe it's not even producing energy. Maybe it's trading energy savings. Maybe it's going to be demand management. Maybe it's going to be, trading on energy efficiency, like reducing my overall load, and I'm able to monetize that. It becomes then kind of a regulatory, asset, which is code for I'm able to do something with nothing because I have avoided costs that I'm missing out on, right? Like I don't have to spend money here, so this thing has now become valuable. And then the other part of it is maybe it's a combination of all of these, right? Just like with a hybrid energy solution, I may have to have some solar and some generators and some battery, or I maybe have to be connected to the grid to make it work. Green energy projects might be the same way. I mean, for your home, you're going to have a salesman show up. They're going to do a pro forma. They're going to get your proposal, and you're going to finance it. And you have one bill for that. Maybe on one of these larger commercial or utility green energy projects, I'm going to have my construction financing, and I'm going to have my bridge loan, and I'm going to have my perm financing, and I may have some kind of sales funding agreement for the energy, and I may have some grants that allow it to be possible, and I'm going to have a tax equity piece, and I may have to have an independent organization set up to make sure that I take full access to those benefits, and I may have to have some kind of wheeling and transfer agreement or a lease to make it possible. So it may be a whole stack of things that are able to reduce those funding gaps to the point where this is a great project, for your for-profit partners and your nonprofit partners and everybody. So making sure that you have your head wrapped around who the stakeholders are, what their investment and involvement is, really helps kind of address those funding gaps. And some folks will say, oh, well, we'll just take the hit on a capital project and do it because we believe in it. But, as these become more competitive, you just want to make sure that you understand that there are resources out there. There are other funding sources that make these easier, make the payback better. And that may be one of the things that makes or breaks a project is your ability to find and use those additional kind of funding resources. And then being able to understand, what really are your investment criteria and how do you get there? I did a lot of energy efficiency projects where, we were close on their investment criteria, and bringing in an efficiency incentive made it very much possible to do the project when before it wouldn't have, passed the finance test. And so that allows, you to do better projects. And one thing about that is kind of the performance assurance, right? So these projects, whether they're replacing existing energy, whether you're marketing that energy to somebody else, whether it's just an asset in your stack, the reason you're doing it is for some sort of outcome, right? Whether it's energy, whether it's cost, whether it's carbon reduction. One of the hardest things, I think, let's see. One of the hardest things is people invest in these projects, right? And they do them and they get excited about them. They maybe designed them to do a certain thing, and then at the end of the day, when they're finished with the project, that requirement changes. That thing changes that they want. Maybe they wanted to offset, all of a certain amount and be able to put fleet chargers in or something like that, right? And so they did all of the investment, they did all of the project, but at the end of the day, they don't use it the way that it was designed. And it ends up, especially in the energy space, not only being a loss and a sunk cost there, but then there's going to be a complete replacement cost down the road. So let's say I'm doing solar, but all of my load's at night and I didn't put any storage in and I can't get a net metering agreement, or it's so big that the utility won't take it without me losing some amount of the value, something like that, all of a sudden those benefits that were going to make the project possible are gone. And so ways to overcome that is make sure that you start with the end in mind on these projects, right? That you know what you're trying to get out of them. Again, not everything is about your energy or your costs, right? It may be about something else. It may be about doing something for a certain amount of time and then going back to a technology that's different or having a different payback. All of those things kind of start at the design phase, at the inception phase, and make sure that you've got vetted partners who've done this before. As the economic incentives to play in this space change, so do sometimes the players. And there are a lot of opportunists out there. So just make sure that as you're working with folks to develop projects that they know what they're talking about, that they've done this before, or that they have valued partners that they work with, to make sure that what you're buying is what you need or what you want, because there will be a lot of things that maybe don't match if you don't have the right partners, if you don't have the right outcomes from the beginning. We were working on designing a municipal building for some folks, and they wanted to do this LEED Platinum net zero, really intense project. And that was their goal from the beginning. And by the end of design, it was essentially a code compliant project because the people that championed that piece of it weren't able to bring the resources to the table to make it happen or to continue to push that vision forward. And I think we run the risk of losing that if we don't have, commissioning, monitoring, improvements, throughout the process. So ideally, you're going to want to have a consultant of some sort, third party commissioning, to make sure, hey, it's designed the way we want it, it's sized the way we want it, it's working the way we intended, right? And so bringing in a commissioning partner, make sure that it's safe, compliant, that it does what it's supposed to, that it's sized right, all of these things. And I think that helps with your level of confidence, even with your investors. They may want to bring in a third party, they may require it, or you having one gives them a higher level of confidence in your project. Once you've done the project, you go through the checklist, everything works the way it's supposed to. It may not stay that way. So there was a government building we were working on, about 6 years old, phenomenal building, built to our state high performance building standards. And what we found as we went in to recommission this building was that at initial inception, all of the systems worked. And all of these really dynamic controls that had been installed had been put in hand mode and turned off. And so everything had been manually configured and it wasn't working the way that it was intended to. And so what happened is, as we went in, commissioned, turned on these automatic controls and this balancing and everything, we saved about 75% of the energy that the building was using, combined between electric and gas. I think it was like 40% of electric use was reduced because we went in and we checked to make sure that what we'd intended was happening, right? And so that's an important piece of these projects, is we do them, we get them set up, but then throughout their life, because the value we want comes from the energy savings or the energy production or whatever, that we keep an eye on that, right? There's some really fantastic, real-time monitoring systems that flag, a lagging solar panel or, an error or those kinds of things, so we can do preventative maintenance to fix that. Caterpillar has predictive maintenance software where we can, based on the way that something's running, tell you, whether or not you need to do preventative maintenance before or after, or if there's an issue, and, be able to, even predict those costs down to understanding what the life cycle of a project is. All these things kind of work together, from the beginning phase, right, of I have this idea to funding, to design, commissioning, and then monitoring and life cycle. All of them work together to make these projects work. Because it's not just a one-time, oh, we want solar and it's great. We're integrating solar into what we're doing as a company or as a building or as a facility, or we're integrating it into the utility that we're a part of. And again, it's a long-term project, right? You're going to have somebody to manage it and monitor it. Which in general, a lot of people are like, I put a switchboard in and I test it once a year, and that's the end of it. These are a little more involved in that. I think being able to have our eyes wide open to the complexities of green energy projects, especially as they're still evolving, allows us to do a lot more with them, and then recognize and capture that value rather than just hoping that it's there. And I think that was one of the problems with commissioning, is we had everything worked, so the building was put into service, but the value wasn't realized because of lack of awareness of why some of these things were done. So
Steve, it looks like there's a question. Steve, looks like there's a question.
Sure.
I think it's related to this cube. And Brian Puckett asks, is that cube showing year-over-year capital spend, or is the capital spend portrayed as financing? Good visual. I just thought the capital would go down over time instead of up.
Yeah. So sometimes it does. The little green triangle on the top actually does show that there's a reduction in the capital costs. Sometimes it's a replacement cost, right? Like that I am, 1 for 1, or 1 for 2, or half for 1, replacing that cost. It just depends. There's a lot of variables. Things are all over the place. But the green cube there is going to be the customer savings. So initially that block would have been the whole thing. And as I bring up that generator, that PV and wind, the hybrid, I'm able to reduce that initial fuel cost. And so those savings are going to be part of this spend here. So I think I can get my cursor over there. And so there are somewhat significant savings in this project. And that can be used to help finance it, right? Like, so if I have these savings, I can take what we would have invested in capital before to pay off my wind, to pay off my solar battery, those kinds of things. And that's a lot of the reason you do this, is to kind of help pay for those. But that performance is what makes it work. Brian, did that answer the question?
I'll have to wait for him to give a thumbs up or respond in the Q&A, but you can proceed, Steve.
So I've kind of gone through a lot of things. I could talk about this for a long time. But on the performance assurance stuff, I just want to go through kind of a couple of ideas here. This is for a building retrofit program. Could be applied to anything. As you develop your scope of work, use real data. Make sure that you've got the financing available, whether that's savings, whether that's commercial money, whether that's grants and tax incentives. Make sure that you've got some of those resources available. Do the project, and install and commission. Again, make sure that it's done right. And at the end of the day, go and make sure that it's happening. Watch the performance of the building, compare your bills before and after, and then as you find either you're doing better or worse, make those necessary corrections. I wish there were a solution that was perfect for everybody in every situation. We many times we'll bid a project, a utility will put an RFP that says we have an all sources need. So pitch everything you've got, and then we'll balance, based on fuel costs and capital costs and O&M costs and life cycle and everything, what we need to put in our portfolio to get back out the energy and reliability that we want. So there's not a magic bullet. There's not a standard technology. In general, yeah, there's reciprocating and turbines that run on everything from coal to natural gas to hydrogen to a combination of all of them, and in between, there's PV, there's gravity fed and water fed storage, dams, hydro, all of that stuff. There's lithium ion, there's chemical and thermal batteries, there's concentrating. So there's a ton of technologies, and each of them have their place. Each of them have their paybacks and needs. And so what we see at this point, and the utilities and the commercial customers that are buying, is that working together with all of these different technologies, we can continue to bring more renewables in, reduce our fuel costs, reduce our carbon emissions, all of these things, to have a healthier and more resilient grid, right? If we replace it all with one thing, it wouldn't work. And so we're continuing to kind of edge this along, better technologies, bringing in nukes. And there's modular nuke testing going on right now in Wyoming, and lots at Idaho National Lab, and those things. All of those things work together, at a micro and a macro scale to continue to, provide the energy we need to have our way of life, and for us to continue to incrementally and in this value stack have different technologies. We have to balance the risk, the performance risk, the finance risk, whatever else, with the benefits that we get out of it, and then find those gaps and close them. And that's kind of the hopefully the takeaway from this is, as we work on this, we're going to have a better grid. We're going to have, better opportunities for finance, for R&D, for all of these things. And we've got a lot of partners, finance, equipment, technology, that are working towards, a better solution. And I'm excited about it. And there's a lot going on there. So, I think we've got a couple more minutes for questions, Brian. So Ken did have a question. Typical lifespan of solar panels and batteries. So there is a production curve for solar panels and batteries. Generally, when you're starting to talk about full capacity of a solar panel, you're going to be 1.5% a year degradation until about maybe 25 years. They'll continue to produce, but the technology innovations, the densification of what we're able to put on a panel, all of those things, you may end up repowering them before 25 years, but 25 years is going to be about the lifespan of your solar panels. A lot of times they're going to start tapering off pretty hard about 15 years, but there's still value in them. So, once they're paid off in about 15 years, they're still going to generate, it's just not as much. And so a lot of that's going to be just a strict, do I want to pay my power bill or do I want to pay the solar company, argument. But yeah, that's a good question. And they're still working on technologies to recycle. I think there's going to be a lot more solar panels coming off service to be recycled, in the next few years. So if you have a brilliant idea around that, you could be a billionaire. There's going to be, a lot of replacement technologies, a lot of, kind of innovations as electronics get better, and they do, better, better alloys and composites and everything else. So, we're able to improve these things. So, yeah, 10 years, probably on your battery, depending on the way you use it. If you're using it more than once a day, it's going to significantly go down. We're about 4,000 cycles on a lithium ion battery. Those lithium ion batteries are good. They're relatively stable as long as you manage the thermal load on them. there's a lot of safeguards put around them, but they're not super efficient. You're going to have a top and a bottom charging limit. You're going to have a few other things. So you're going to get about 50% of the capacity of a lithium ion battery available to you. You'll get your full power rating out of it. This is a megawatt battery. You're going to get a megawatt, but your energy rating is going to be throttled somewhat because of electronics and transformation and limits on charge and those kinds of things. So they're going to last between 7 and 10 years, depending on how you do them. Again, there will be some end of life cycle stuff with those. I think we're still working out, but in general, you're going to replace your batteries 2 or 3 times before you end up doing your solar panels.
Nice. Yeah, and I know here in downtown Boise in particular, there's a lot of use of geothermal that you probably are aware of. A lot of the buildings and state buildings are heated with geothermal. Oh, good use of the renewable resource.
I love that. The most exciting thing about that is just the major reduction in fuel and electricity that you can do. They're a little finicky if they're not sized right, if the heat sink's a little off, like those kinds of things. Then you're back to that. Well, I not only have to replace that, but I have to replace it in full. Argument with something less efficient, but if done right, phenomenal technology and low carbon too, which is nice. Yeah, for sure. I didn't see any other questions out there. So with that, thank you, Steve. Very informative, good stuff. And I appreciate you taking the time with our chapter membership. And everyone, just hope you have a good rest of your day. And Steve, we'll be in touch for another future presentation, either you or one of your colleagues. Yeah, and there's my contact information. If you have
excellent
questions about renewables, hybrids, finance, we definitely would love to be a resource as well. So
awesome. Thanks for
so much
sharing
for having me.
You bet. Take care, everybody.